Welcome back, guys. Now in this video we'll talk about the matrix operations. So while we are going over the matrices, because as we said, the matrix are the basic of MATLAB, so we should understand the basics of matrix and their operations in order to go on in MATLAB. So guys, I will start with the first trivial operation, which is the equality. So what does this mean? So if B matrix is equal to A matrix, this means, guys, that all the elements of B is equal to all the elements of, or are equal to all the elements of A, and this means, guys, that B should be of the same size of A. Because in fact, guys, if B hasn't the same size of A, B is not equal to A. Now the second operation is the sum. In order to do the sum of A and B matrices, A and B should be of the same size. Otherwise, I cannot do the sum. So the sum couldn't be possible if A and B do not have the same size. And in this case, C, which is the answer of this sum, will be also having the same size of A and B. Let's take an example. So guys, assume that this is A. 3, 2 minus 1, 0, 1, 4. Now what is the size of this A? Basically, I should always start by the number of rows, which is here 2, and the number of columns, which is here 3. So it is 2 times 3. Now of course this is A 1, 1. Let's say this is what? A 2, 2. Now this is what? A 2, 1, and so on. So you will always have that the last element of this matrix, which is here 4, has the index of the size of this matrix. So this is always A2, 3. Okay, of course, without this cross sign, alright? Now, in order to do the sum of this A with a matrix B, B should have the same size of A. So let's take an example of B having the size of 2 times 3. Okay, so assume that this is B minus 105 minus 0.5 10 1 over 4. Now the size of B here is also 2 times 3, which means I can do what? I can do the sum. Because the only requirement of the sum between two matrices is that they do have the same size. Okay, now the answer of the sum should be what? Should be C, and C, guys, should also have the same size of what? Of A and B, which is 2 times 3. Alright, so C will have 2 rows and 3 columns. Now, C11 will be, of course, the sum of the first element of A with the first element of B, which is 2. C12 will be the sum of A12 and B12, so it is 2 plus 0, 2. Now this one is minus 1 plus 5, 4, 0 minus 0.5, 0.5, 1 plus 10, 11, 4 plus 1 over 4 is 4.25. Okay, so this is how you can do the sum. Remember, if they do not have the same size, I cannot do this sum, so it is trivial. Now, if I'm gonna do the product of the matrix A with a scalar number alpha, so any scalar number alpha, I know that alpha is a scalar number, so it could be negative or positive, and I'm gonna do its sum with A. So basically, guys, this doesn't have any requirement. So for any matrix A, you can multiply this matrix with any scalar number. In fact, the requirement is basically in the result. So if B is equal to alpha times A, B should be the same size of A. Okay, so let's take an example. So assume that I'm gonna multiply this matrix A with a number that is equal to minus 2. I can do this, and I can also say minus 2 times this A, it is the same. Now what will be B? B will be the same size of A, which is 2 times 3. And Bij will be equal to Aij times this alpha, which is here minus 2. So it is minus 6, minus 4, 2, 0, minus 2, and minus 8. So this is B. Of course, B has the size of 2 times 3. Okay. The two most important operations are basically the product and the inverse. So I will keep these two operations to the last, and before doing these two, I will do the transpose, because the transpose is also very trivial. Transpose of A prime, AT, it has a lot of symbols, means, guys, that Bij is equal to Aji. So as if I'm flipping the rows with columns. So let's take the same example of A. I'm gonna find A prime or AT, which is the transpose of A. What you should do is to flip the rows with columns, which means if A has a size of 2 by 3, then AT, the transpose of A, will have the size of 3 by 2, which means it will have 3 rows and 2 columns. And then, guys, I will take the first row of A and put it in the first column of AT. So this will be 3, 2, minus 1. And then, guys, I will take the second row of A and put it in the second column of AT. So this is the transpose, basically. You will flip the rows and the columns, and then the size will be, of course, n times m and not m times n. Alright? So this is for the transpose, and now let's go to the most important operations. They are the product and then the inverse. Now, guys, how to do the product? It is not as easy as the scalar product. So in the product of matrices, you should understand that there will be a very important requirement, which is the internal dimension. So basically, guys, if I have a matrix A that has the size of m times p, m rows and p columns, if the multiplication is valid between A and B, B should have a number of rows P that is equal to the number of columns of A. So these two here are called the internal dimensions. And what is very important in the product is that the order is very important. So if A times B is valid, this doesn't mean that B times A multiplication is valid, although it is valid in some particular cases. So guys, A times B is not equal to B times A, and more specifically, guys, if A times B is valid, B times A could not be valid. So it could be valid in some particular case, we'll talk about them, but in the most cases, it is not valid. Now, how to do the multiplication? Guys, somehow tricky, so I will teach you how to do it, but I want you guys, before the online meeting, to do some practice on the multiplication of matrices. So let's learn how to do the multiplication of matrices.